Hi, welcome to this video where we're looking at questions from the Specialist Maths SACE exam from 2019. And this video, we're looking at question 3. And question 3 involved doing some plane geometry. So you were given at the start of question 3 a reference to figure 2, which shows a quadrilateral ABCD. Okay, so that's the quadrilateral that's in the diagram below here. It goes A, B, C, D, and the vector AB is given by the bold little a, the vector BC is the bold little b, and the vector from C to D is the bold little c. And we've also got labelled in this plot, or this figure, we've got the midpoint of A and B is labelled as E, the midpoint of B and C is labelled as F, the midpoint of C and D is G, and the midpoint of A and D is H. Okay, and so now we're going to get down to what we've been asked to do. The first is find the following vectors in terms of the little bold A, B, and C vectors. Okay, so we want to find AD. So if we go back to the figure, AD, that's the vector that starts at the point A and goes across to the point D. And you can see if you want to get from A to D using the little bold vectors, you can do that by going up the A vector, across the B vector, and down the C vector. And all of those are in the direction of the vectors. And so we can just say then that AD is given by A plus B plus C. Okay, I'm just using underbars here to indicate the bold vectors. Okay, now EF, the vector EF, if we go back to the figure, EF is involving the midpoints, and so if we use another colour, you can see the vector that we're after is this one, and you can see the vector from E to B is 1/2 of A, and the vector from B to F is 1/2 B. Okay, so the vector from E to F is just going to be 1/2 A plus 1/2 B. Okay, so EF is 1/2 A plus 1/2 B, which is 1/2 A plus B. Okay, now we also want to find the vector HG. And this is worth 2 marks. The other two subparts were worth 1 mark each, so this is going to be a little bit more work, we would assume. And we're after H to G. So H to G, if we look here, we're talking about this vector that goes here, H to G. And so we've got, if we want to get from H to G, what we're going to have to do is go from H to D, and that's the vector 1/2 A plus B plus C. We calculated that in part 1. And 1/2 C is this vector. We want to go along that line, but in the opposite direction. So we want to subtract off 1/2 C. Okay, so it's important to remember when you're going in a positive direction, you're adding. When you're going against the direction of a vector, then it's the same as subtracting. And so we're going to get 1/2 A plus B plus C, and minus 1/2 C. And so that's going to leave us with 1/2 A plus B. And we've seen this before. Okay, so the vector 1/2 A plus B has come up before because that was the answer to part 2. It was also 1/2 A plus B. Okay, that was the vector EF. So what that's saying is that these two pink vectors here are the same vector. So they point in the same direction and the same length. Okay, so that's going to be important in a minute. Okay, so we now move to part B of the question. In part B, part 1, we will need to explain why EFGH is a parallelogram. Okay, so being a parallelogram, what it means is that it's a quadrilateral and opposite sides are the same length and are parallel. Okay, and we've already shown that the vector EF and the vector HG are the same vector. And so what that tells us is that EF has to be parallel to HG. And it also has to be the same length. And if they're the same length and they're parallel, then the vectors in the other direction, so let's do these, I don't know, this blue color, which is the vector, say, from E to H and the vector from F to G, these also have to be the same length as one another. Okay, so this vector is the same length as this vector, and let's get this color, this vector is the same length as this one, and they're also parallel to one another. Okay, and so to answer this question, all we need to say is, since EFGH is a quadrilateral, with two opposite sides that are equal length and parallel, this is sufficient for EFGH to form a parallelogram. Okay, so that's why EFGH is a parallelogram. And now we want to show that the area of EFGH is given by this expression here. Okay, so to do that, what we're going to do is use a nice property of the cross product. And a nice property of the cross product that we're going to use is that if you get two adjacent sides of a parallelogram, then the area is given by the cross product of those two sides, well, the magnitude of that cross product, because the cross product will give you a vector, and the area is a scalar quantity, and so we need to take the magnitude. Okay, so EF is one side that we can use. So the vector EF we worked out before was a half A plus B, and an adjacent one is, say, the side EH. And if we work out EH, it's basically a half A plus B plus C minus a half A. So it's a half B plus C. We put under bars. Okay, and we can see that if we go back to the figure, we've basically got this side here, and that's a half A plus B plus C. And this is a half A, but to get from E to F we have to go backwards. We have to go in the opposite direction of a half A. Okay, and so it's a half A plus B plus C minus a half A, and so it's just a half B plus C. Okay, so with that sorted out, what we're going to do then is say that the area, let me start that again, is equal to the magnitude of EF cross with EH. That's the magnitude, getting ahead of myself, of a half A plus B crossed with a half B plus C. Now the two scalars of a half can come out front, they don't change anything, they're just multiplying the result. And we can distribute the cross product over the addition, and we get A cross B plus A cross C plus B cross B plus B cross C. And finally, B cross B is equal to 0. And that comes about because whenever you take a cross product of vectors, if it's the same vector, cross product of a vector with itself, it always gives you a 0 because they point in the same direction. And vectors that point in the same direction have a 0 cross product. And so we're left with a quarter A cross B plus A cross C plus B cross C. Okay, and that's what we needed to show. So that's all we needed to do for question 3. So if you have any questions about this video, then leave a comment below. If you like it, click the like button, and if you want to hear about more videos as they come out, then subscribe to the channel, and you can hear these videos or hear about these videos as they're published. All right, thanks very much for listening, and till next time, goodbye.